Today we're going to be drawing pyramids, and we're going to be drawing them in our console application type, and we're going to let the user decide how big they want their pyramid to be. For example, if the user types in 45, then a pyramid is going to be generated here, and it's going to be 45 lines high. As you can see right here, it looks pretty cool, doesn't it? However, if the user enters the number 5, for example, then their pyramid is only going to be 5 lines high. So this is a bit of an exercise. It's not only going to test your C# programming skills, but it's also going to test your logical ability, how you can kind of look at a problem and develop a solution by breaking it down into little subgroups and then sort of attacking the problem. So I'm going to solve this issue, and I'm going to show you how I would approach this task so that you can see how my mind works and how I approach this particular problem. It's quite common to see exercises like this when conducting a job interview, for example. The interviewer might ask you how you develop a small bit of software to generate a shape or a pyramid or something like that. Because anyone can look up syntax and code on the internet, but what a lot of employers like to do these days is to test how your mind works, like logical thinking, see if you can come up with a solution on the spot and also perhaps under pressure. So I'm going to develop a solution for this, and I'm going to show you how I think about this step by step so that you can see how my mind works and how I approach this problem. So let's get going. So the first step is to analyze the problem. When the user enters a number, this denotes the height of the pyramid. Not only the height of the pyramid, but the number of lines that are drawn. You can see there's 5 lines here. The pyramid terminates when there's £1 symbol, and the base of the pyramid covers the whole line here. But you can see here it's the height of the pyramid, which is denoted by this number. So the pyramid is 5 lines high. So that's one thing to note. The second thing to note is that all of these squares are populated. If they're not populated by hashes here, the pound symbol representing the pyramid, then they're populated by the background, which are denoted by hyphens here. You can see the top of the pyramid has £1 symbol, and then on both sides it has 4 hyphens. The next line, you can see the pyramid increases by 2, so instead of 1 here, it's now 3. And then there's 1 less hyphen on each side. Again, below, the pyramid grows by 2 per line, and then the hyphens shrink by 1. So we have a couple of rules here. Each new line, the pyramid grows by 2, and each new line, the hyphens shrink by 1 on each side. One last thing to note is that in this example, where I have a pyramid height of 5, we have 9 characters along the width here. So 5 down and 9 wide. So we have a lot of data to work with. So let's see how we can develop a solution for this example. So if you followed our tutorials previously, you may have seen the example we did when we drew a cube on the screen. Now this exercise is a little different, it's a little more complex, but the principles and procedures behind the scenes are quite similar. In that example, we used some loops, we used for loops, and this example should be no different. When we see repeating data like this and like this, in our head we should be thinking, okay, a loop must be involved. Something must be looping around and iterating to generate these hyphens here. And then maybe we need another loop to then generate these pound symbols, and then maybe a third loop here to carry on with the hyphens. There are a few ways we can approach this problem. Maybe we could have one loop where we just switch the character for the pyramid part. Yes, that may also work. And when developing solutions like this, there are quite a few solutions to the problem, but the choice is yours. And when you make that choice, you want to make the easiest, most time-efficient one, but also generate the code which is more maintainable by yourself in the future, but more maintainable by any teammates which actually take on your code and develop it in the future. So there's lots of things to think about. So I think the way I would approach this problem is to have a main loop going down the y-axis. So we have a main loop which generates each line in turn. Then inside that loop, I will have one loop that generates these hyphens, a second loop that generates the pyramid part, which is this, and then a third loop which continues with these hyphens. So one main loop, which does the y-axis, then inside that loop, I think 3 separate loops. That's a perfect solution for approaching this kind of problem. So let's take a loop at that now and see if we can develop something like that. So here's the code we have so far. It's not really doing anything at all. It's just outputting some messages to the user, welcoming them to the software, thank you for using the app, this is what it does, and then we're asking the user the question. We're taking the user's input, converting it to an integer, and storing it into an integer variable. Now what I want to do, I'm going to create a method, because when I create a method, I can call it multiple times from multiple places, and then I can generate pyramids from wherever I want. So I think all the logic for generating the pyramid of the custom size here should belong in a method, and then it's easily reusable by anything else. So I'm going to create a method template now. The method won't have a return type because I just want the method to draw the pyramid. It's going to create one parameter, and that's just going to be the size of the pyramid. So there's our basic method there. So the first thing I said I was going to do was generate a loop which would print each line in turn, and that would go down the y-axis. So I'm going to create a loop to do that. So this loop here represents the height of the canvas, so the height of the pyramid in this case, because the pyramid touches the top of the canvas that we're drawing on and also the bottom. It's safe to say that whatever number the user gives is the full height of the pyramid. We have no background above the pyramid and no background below the pyramid. So doing the y-axis from 1 less than or equal to the size of the pyramid and incrementing by 1 will ensure that we draw the pyramid along the y-axis, so going down. Now inside this loop, I mentioned that a possible solution was to have 3 separate loops. The first one to draw the hyphens on the left-hand side, the second one to draw the pyramid, and the third one to continue with the hyphens on the right-hand side. So let me set up those loops now. So without really thinking about writing code, for example, I already have this nice template, and I've just generated this template from just logically thinking about the problem. I need some kind of loop to draw downwards for the size of the pyramid, and then inside on each line I need something generating the pyramid and the background on each separate line. So already I have a nice little template here without really thinking about the problem too much. So when we draw the hyphens on the left, the only thing we want to do is output a hyphen to the screen. So let's do that now. And similarly, when we draw the hyphens on the right, we're going to draw a hyphen. And similarly, when we draw the pyramid, we need the pound symbol. So pretty much the only thing we need to do now is work out when these loops terminate. So when we looked at the example before and the user entered number 5, for example, then the pyramid had a width of 9 but a height of 5. And the very first line of the pyramid had 1 pound symbol, but it had 4 hyphens on each side. So we need to work out when to stop drawing hyphens. And to work out when to stop drawing hyphens on the left-hand side, we need to work out when to terminate this for loop. Similarly, how wide we should draw the pyramid on each side, and also when to stop drawing hyphens on the right-hand side. And when developing software like this, some days you'll have ultimate clarity. This will be easy for you. You just type in the values, you're having a good day. But sometimes if I'm just tired or I'm not in the right mindset, or perhaps you're a beginner and you're kind of working through it in your head, well then it's no shame using something like Microsoft Excel or a notepad just to kind of plot all your figures, so then you can use your spare brain space to work out a solution for the problem or perhaps anything else. So there's no shame making notes or anything like that. It's perfectly normal. So let me open Excel and plot some of these figures here. So I've opened up Microsoft Excel here, and I've mapped the solution here. Well, an expected solution anyway. If the user enters the number 5, for example, then we know our pyramid is going to be 5 units high. So when the user enters 5, it's going to generate a pyramid that looks just something like this. So the solution we've developed so far, I have a loop which prints each line in turn, and that's our main loop. And we denoted that with y. You can see here, I just called it the variable y. Y equals 1, and it goes all the way to the size of the pyramid, less than or equal to. So what I'm going to do, I'm going to put the variable y right here. The next thing, inside this loop, I have 3 loops. One will generate this content, the next loop will generate this content, and the third loop will generate this content. So I'm also going to put that over here. So this is going to be the first set of hyphens, H1. This will be the pyramid, and this is the second set of hyphens. So now, when y is 1, so this is the first time our loop loops, we want to generate 4 hyphens on the left. We want to generate 1 character for the pyramid, and also 4 hyphens on the right. When y is 2, now our loop is repeating for the second time. We're generating this line. Our first loop will generate 3 hyphens. Our second loop will generate 3 segments for the pyramid. And again, the hyphens are going to be the same on the right. So then 3. And then the third line, you can see where this is going. So 2, the pyramid will be 5, and the hyphens 2. Then line number 4 and line number 5, I'm just going to fill out now. So you can see here's some figures on how many characters will be printed for each iteration of the loop. Now using this, you can kind of work out what you need to do. You have more clarity in your head. You don't need to remember these numbers. You can denote your brain power to thinking about a solution to the problem. So let's look at generating a solution to this problem. When the user enters number 5, then 5 is the size of our pyramid. So our variable size, which comes into our method, will be 5. The first time the loop is run, remember y is our loop, the first time the loop is run, y is equal to 1. We can see that when y is 1, the number of hyphens on each side here is 1 less than the size of the pyramid. The second time the loop is run, you can see the hyphens on each side is 2 less than the size of the pyramid. So you can see a bit of a rule here. You can see that when the size is 5 and we subtract 1 from the size, we get the number of hyphens on each side. When y is 2, so 5 take away 2 is 3. 5 take away 3 is 2. So you can see to generate the number of hyphens on each side, we take the size of the pyramid, in this example is 5, and subtract y from that. And what that will give us the number of hyphens on each side. So let's look at generating those hyphen loops. So these are the 2 loops that generate the hyphens on the left here and also on the right. We said that the number of hyphens for each line is the total size of the pyramid, and we subtract y from that. So we just say size minus y. And to add clarity, we put brackets around there. Then it adds more readability. So I'm pretty confident now for each line we're outputting the correct number of hyphens on the left and also on the right. What a lot of developers tend to do is run the application early. There's a couple reasons for doing that. 1, you can see if your last change was correct. And 2, you can kind of just, look at the current state of the application. If anything, it gives you a bit more enjoyment to see what you've done already. So let's take a look now. We're actually calling the method now. So we're taking the user's number, we're calling the method, and then this method is getting executed. Let's take a look at the results so far. So if I type in the number 5 now, you can see everything is on one line. So why is that? That's because after all of these 3 loops, we're not actually outputting a brand new line. There's a bit of a problem here. And also, every time we output a character, we're outputting a brand new line too. So that's also a mistake. Every time we output a character, we don't want to write a new line. We just want to write that character. So we use console.write to do that. And when we actually want a new line, well, then we're going to do that after all of these loops. So let's take a look at the application now and see what it looks like. So you can see now we have a bit of a rhombus shape. It looks quite interesting. But you can see that the number of hyphens is correct. We start with 4, 3, 2, 1, 0. So now we need to fix this middle section here, which is the pyramid. Let's take a look at how to do that. So I'm going to go back into Excel. So I'm back in Excel now. So what I want to do is find out how to generate these numbers using our information available. We have the size of the pyramid, and we also have the value of y on each iteration of the loop. We've already done the hyphen amounts for each line. It looked quite simple to do. But how do we generate this number using the information we have? So on line 1 here, the pyramid is 1 character. You can see there. On line 2, the pyramid is 3. So you can see on each new line, the pyramid increases by 2 pound symbols. So 1, 3, 5, 7, 9. So they're all kind of odd numbers here. So how can we generate these numbers using the information we have here? For those of you that are good at mathematics, it's probably quite easy for you. But sometimes, developers aren't really good at mathematics these days. Maybe in the 70s and 80s, where all mathematicians and physicians, did a bit of programming, it was quite obvious. But these days, it's IT, programming, it's a bit of a separate skill. So sometimes it doesn't translate directly to mathematics. But if you notice here with this y value here, let's take the number 3, for example. If we multiply 3 by 2, we get 6. And then we subtract 1 from that. And then we get the value 5. Again, maybe 4, for example. 4 times 2 is 8. Subtract 1 is 7. 5 times 2 is 10. Subtract 1 is 9. And I think that's a rule that might work all the way across the field. But we should always test with 1 and 0 in cases like this. So 1 times 2 is 2. Take 1 is 1. Yeah, that seems to work too. So I think that might be a rule that works. So what we can say is P is equal to y multiplied by 2 take away 1. And that is a rule that should work for generating the pyramid based on the line number itself. There might be a lot more solutions to this problem, but this is certainly one that would work for us based on y right here. So coming back into our software here, we have the value of y on each iteration of the loop. So what we do here, we want to generate the pyramid on each line. So when y is 3, for example, then we want to generate 5 of these pound symbols here. And we said that p is y multiplied by 2 and then subtract 1 from that. So it would look something like this. And I believe this would work, but to add a bit of clarity, I always use extra brackets like this. It just makes it more readable so we can see what's going on. But you would get the exact same result using this due to BIDMAS because multiplication comes before subtraction. But in cases like this, I would always write it like this, for example. So let's take a look at the example now and see what's going on. So if we input the number 5, you can see now we get a nice pyramid. That's pretty cool, isn't it? Does this work for bigger numbers though? So let's say 35. So that looks pretty good. Yeah, it looks like it's working. So you can see this is how I would approach a problem on something like this. We pretty much wrote 90% of the code by just analyzing the problem. We didn't need to really think about CSharp and programming. We literally just looked at the pyramid, kind of dissected the problem a bit and broke it down into smaller chunks. The only bit that was difficult was finding out the bounds for these for loops. So how many hyphens we should draw, how much of the pyramid we should draw on each line, and again the hyphens on the right. And also a little complication about new lines and things like that, which is kind of normal sometimes. Everybody makes mistakes, it's normal. But you can see how we isolated these problems and used Microsoft Excel to sort of run the figures, so we didn't really have to hold all of this information in our head. We can just sort of take the problem here, dissect it all down, run all the figures, then we just have to work out how to get these figures from the information we have, either the height of the pyramid or the value of y on each iteration of the loop. So you can see how we broke the problem down without really thinking about it. We didn't really use any brain power. Everything in our mind was dumped into Excel, and we can sort of work out a solution from that. So that's how I would tackle a situation like this. Especially if I was really tired or hungover and I couldn't think, then, let the tools do the work for you. So coming back into Visual Studio now, we're drawing pretty cool pyramids. We can even replace the background with a nice empty white space. And maybe we can draw two pyramids. I mean, we put it in a method, so, now we can repeat the method a lot more easy, and that's the power of methods. So if I now put in the number 5, for example, now we're generating 3 pyramids on top of each other. So that's pretty cool, isn't it? So anyway, that's how I would approach a problem like this. Again, it's a common thing you may find in job interviews. But really, the power of a programmer is to test logical thinking. How does your mind work? A good programmer is not somebody that can remember syntax and regurgitate information. A good programmer is someone that can think logically, break down a problem, and find a suitable solution. That is what a good programmer is. So I hope you found this exercise useful, and thank you for watching.